So today we are going to wrap up solving equations and pretty much begin reviewing for the chapter 6 test on Monday. So that gives us today and tomorrow to review. The review worksheet is a pretty thorough review worksheet containing the concepts that we talked about in chapter 6, which chapter 6 goes back a good way. Like we talked about first simplifying all the radical expressions. We added them, subtracted them, multiplied and divided radical expressions. That's when we started chapter 6. And then chapter 6 went into rational exponents, the properties of exponents, but working with fractions as an exponent instead of whole numbers, and being able to write an exponent as a fraction into a radical. We then talked about inverse functions. We talked about combining functions and the composition of functions. Finally, we looked at graphing and the solving. So there was a lot of stuff that I just kind of listed in chapter 6, which I compare it to chapter 4, because chapter 4 had all those different ways to solve quadratic functions by factoring, completing the square, using the quadratic formula, using square roots. So the concepts, the amount of concepts in chapter 4 in this chapter, there's a lot with it. And this was only 6 sections. Chapter 4 was 8 sections. So we're going to look at the last 2 questions from the homework, questions 19 and 20. Number 18 was worked out for you in the answer sheet. So if you had questions on 18, check the answer sheet out, which you should be doing anyway, checking your answers, but look at the worked out solutions. And I apologize that that answer sheet, I guess when I solved it, it flipped it so that it was not nice to look at. It's kind of on its side. So apologize for that. But if you want to go to the homework assignment, the worksheet from yesterday, we'll start with number 19 as a nice little review of an equation that contains 1 radical, and then we'll look at 20 with the equation that contains 2. So x is equal to 5 plus 3x minus 11 to the power of 1/2. And the power of 1/2 we know is also a square root. So I could have said, all right, I'm not going to keep that power of 1/2, and instead I'm going to write it as a square root. That's kind of a way that we can think about solving it. It means the same thing. I can interchange the notation. So Ava, what would you do first to try and solve?
So you multiply by 2 over 1 in the exponent on the other side?
Yes, but there's something that you probably want to do first before that.
You subtract it.
There you go, yeah. You just figured I already knew that step, huh? All right. And then if you keep it as a 1/2, which you totally can, she's saying you're going to multiply by 2, and that eliminates the radical of 1/2. Or if I have a square root, I would want to multiply or raise it to the power of 2. And remember, it's a quantity squared on the other side. So that's the key, thinking those 2 terms are held together like glue to create a quantity. And then what happens, Ava?
You factor x minus.
What do you get when you multiply those 2 together? Just a final answer there. Good. And then on the other side, the radical and the power cancel and just leave us with 3x minus 11. Questions so far? So we eliminated the radical. Actually, we isolated it first. Then we raised it to the power to eliminate. And now we have to do some algebra to get this to solve, which takes us back to chapter 4 because this contains now some factoring. Set it equal to 0 by taking these 2 terms to the other side. And Ava, once you set it equal to 0, what's the expression that you get that quadratic?
X squared minus 13.
Yeah. So we're looking at 36. 2 factors that multiply to be 36, but combine to be 13. Well, 9 and 4 multiply to be 36. If I make them both negative, they combine to be negative 13. Again, the nice thing about these problems, you should have noticed that the coefficient in front of them was a 1. So anytime the coefficient is a 1, those factors just go directly in parentheses. And then I can just say, well, this one is equal to 0, and that one is equal to 0. So they must equal 9, and they must equal 4. It's a really thick pen. Must be zoomed in pretty far here. Any questions? Jaden, are we done?
No, you have to go back and check the book.
And why do we need to check it?
Because one of them is an extraneous solution.
Yeah, one of them could be extraneous. So go back and check your solutions. Don't stop. So we have extraneous possibilities here. So if I plug in the 9, so 9 is equal to 5 plus, I'm just going to keep it with the square root, 3 times 9 minus 11. 3 times 9 is 27, minus 11 gives me the 16, and that makes 5 and 4. Again, when you're just taking that square root, there's a plus sign in the middle of it, 5 plus the square root of 16, so it becomes 5 plus 4. That works. 5 plus 4 does equal 9, so this 9 is a solution. If I plug in the 4, I have 3 times 4 minus 11, which gives me 5 plus the square root of 12 minus 11 is 1. I'm pretty sure that 4 is not equal to 5 plus 1. So that one is false. It does not equal it. And that means that 4 was our extraneous solution. Questions? Every once in a while, you will end up with one that has no solution. And that means that graphically, it's graphed above the x-axis. So when you're solving for x, you're really finding one is across the x-axis graphically. Anytime you find x, it's the location where it's crossing the x-axis. So every once in a while, a graph, if we looked at the graph, might start above the x-axis, and that's when it has no solution. And that's when you get through all that work, and you're like, oh my gosh, there's no solution, and I did all that work. But there is no solution for a reason, because everything goes back to the graph. Questions on 19. So looking at the last one, number 20, this was one that contained 2 square roots. When you have 2 radicals, 2 square roots, you want to get 1 radical on one side and 1 on the other, so that you have 1 on each side of the equal sign. Because the second one is being subtracted, the easiest thing to do is to take that square root of 10 minus b to the left side by adding it to the left side. So again, you want to have a radical on each side of the equation. So if I add that square root of 10 minus b, you're just adding the whole quantity. I'm not changing anything underneath. We end up with 2 and then plus 10 minus b under the radical. So this looks similar to the 2 problems we did yesterday in class, solving 2 radical equations. Grace, how would you approach a problem when you have a radical on each side?
Square both sides so it gets on the right, but on the left it's a equal quantity.
Quantity, yeah.
So then it would become 2 of them.
Right. So it's a quantity on the left joined together with that plus sign. So when you square it, you're squaring both of them. And then the foiling, just be careful as you're foiling, making sure you're multiplying everything together. Grace, what did you get when you ended up foiling that out?
When I like fold?
Yeah.
Negative b plus 4 square root of 10 minus b plus 14.
And then 3b minus 2. So just going through what she has here. So 2 times 2 gives us 4. There are 2 root square root of 10 minus b, and another 2 root square root of minus 10, square root of 10 minus b. That's how you get 4 here. And then the radicals cancel, leaving you with just 10 minus b. The 14 is with the 2 times 2, and then the 10 minus b. So that's how we get 14 there. The radical cancels if you have a square root times a square root. Are there questions with that step? So because there were 2 radicals originally, I still have a radical remaining, and we need to isolate the remaining radical. So that means we've got to add a b and subtract a 14. So we have 4 root 10 minus b, and on the other side, we have 4b minus 16. Gabby Soul, how would you isolate the radical here? And when you divide both sides by 4, remember every single piece of the equation has to remain equivalent. What you do to one thing, you've got to do to all terms. So both sides by 4 means that you're taking 4b divided by 4 and negative 16 divided by 4. So we still have the square root of 10 minus b, the 4 in front canceled. On the other side, it's b and then minus 4. So again, that dividing by 4 doesn't just affect one of them, it affects both. With an equation, it affects every single term of the equation. If you divide by something, everything gets divided. If I multiply by something, everything needs to be multiplied by that value. And then Gabby, what would you do? Yeah, again, a second time, both sides need to be squared. And this time, that right side is a quantity. It has b minus 4, so that needs to be squared. So we have 10 minus b. Gabby, what is b minus 4 times b minus 4? Nice job. Finally, we set it all equal to 0. We would subtract 10. That's not where the 10 goes. And add b. So we have b squared minus 7b, and then plus 6. So a really long, involved problem. I now have the factor of 6. 1 and 6 combine to be 6. Negative 1 and negative 6 add to be negative 7. Again, please make sure you're placing them in parentheses, 0 product property. 2 values multiply together to be equal to 0. Individually, you can solve them and set them equal to 0. So since individually it's equal to 0, I get a 1 and we get a 6. Questions? After you check this back into the original problem, one of them doesn't work. Is it the one that doesn't work? Yeah. The 1 is an extraneous solution, and the 6 is the actual final answer. Whew. Questions? Ava?
So I had b equals 9 and b equals 6.
You had?
B equals 9, but I still have b equals 6 as well. Because I think what I did is, I moved.
You still move the same one to the other side, right?
Yeah.
This term right here. So, so when you multiply, here's 2, but then there's another 2. This needs to be. Okay, good. I think you're good. Make sure you can write it. Anybody else have questions? Anybody at home have questions? Yeah.
Can you go over number 15?
Sure. Let's look at 15. So 15, we have 18 minus n to the 1/2 and n over 8 to the 1/2. So you could keep it to the 1/2. If you don't like seeing a rational exponent, the 1/2 is the same thing as the square root. So if you'd rather see it written as a square root, feel free to write it as a square root. So an exponent of 1/2 is really a square root. An exponent of 1/3 is a cube root. Jaden, what would you do then? Yeah, we're going to square both sides, square the square roots. Or you could say, well, I'm going to multiply 1/2 by the reciprocal of 2 over 1. You're doing the same exact thing. Just depends on if you're thinking of it as a fraction or you're thinking of it as a radical. So now we have 18 minus n and n over 8. Because the exponents cancel, or my radical and my exponent, my power cancels. So now you have an equation that says 18 minus n is equal to n divided by 8. Jaden, if you have n divided by 8, how would you get rid of that so that the n is by itself?
Would you multiply it by 8?
Yeah, so let's multiply both sides by 8. But again, whatever you do to one thing, you have to do to all of it. And this 18 minus n is a quantity. So that 18 minus n needs to be multiplied by 8. All of that, both of those pieces. So Jaden, 18 times 8 is?
144.
And then I still have 8 times negative n. So be careful there. That makes negative 8n. And that would be like probably the mistake that I would see, the 18 going to the 8 and not the 8 also distributing with the negative n. So you're solving this. There's nothing squared. We just need to take n and get it by itself. So there's an n on both sides. Let's just add that 8 to the other side. And then divide by 9. So does 144 divide by 9 evenly? Ella, what is it? Yeah. Good one to talk about. That one, like, you didn't have to FOIL or factor. It's still a little different, though, with that n divided by 8. Any other questions? Sure. Yeah. I think this is a good one, too. So did you square both sides first? Yeah. Okay. So then we have 8k equals k squared. So anytime there's a squared in your problem, you need to set it equal to 0. So if you have a term that's squared, we need to get this equal to 0. So if we set this equal to 0, we then have k squared minus 8k. The reason we have to set it equal to 0 is so that we get all of the solutions. Anytime you divide by a variable, you're losing an answer because a variable gives you an answer. So if you set it equal to 0, and you have this expression k squared minus 8k, Gabby, what do they both have in common? They both have a k in common. So I could factor out the k. And then once it's factored out, it's equal to 0. Individually, each one of those is equal to 0. So k equals 0 and k equals 8. And if you check both of them, they both hold true because the square root of 0 is equal to 0 if I plug a 0 in. And if I plug an 8 in, the square root of 64 is equal to 8. So both of these are actually the solution. And it doesn't happen too often when you have both being the solution. But both of them work. So make sure you have both answers there, not just the 8, but we also need that 0 as well. These are great questions. So if you want to travel over to Google Classroom, And it is in the stream, so should be the first thing in the stream. This is homework for today and tomorrow. I have it posted once. And then when you look at the post, it tells you the numbers that you have to do for today and the numbers that you have to do for tomorrow. So today I have 1 through 19, tomorrow I have 20 to 36. And we have 20 minutes. So just kind of taking a peek at this. There it goes. It does start off with pretty much being in chronological order of the sections we covered in the chapter. So the first two, evaluating without the aid of the calculator. If you have a radical or a rational exponent, write it as a radical first. But just a little refresher, what happens when you have a negative exponent? Alyssa, do you remember what happens when you would have a negative 4/3 as an exponent?
It would go over 1.
Yeah. And then how do you rewrite that 4/3 exponent? Yeah, as a square root. So it gets written as a radical. Remember, the denominator is the root. So that's the 3. The numerator is the exponent. So the negative makes it a fraction. Rewrite it as a radical. And then Alyssa, what is the cube root of 8?
2.
And then 2 to the 4th becomes 16. So that's no calculator necessary. That wonderful brain power that you have. The next 4 problems deal with simplifying. If it is a square root or a cube root, leave it like that. But number 6 has an exponent. That's a fraction. So your answer should be left as a fractional exponent. So if it's given with a square root, leave it as a square root. If it has an exponent, then your answer would have an exponent. At the bottom of this page would be those operations: adding, subtracting, multiplying, dividing. The 2 functions are given to you up here, f of x and g of x. And then the next page continues with the composite functions and then finding inverses. So I have you stopping at 19 because then like the graphing and the equations would be remaining, which is the concepts we just talked about. So it stops at section 6.4. That's where number 19 ends. So I'm going to give you time to work. If you want to, feel free to ask each other questions. There's a good number of you in class right now. So ask each other questions, ask me questions. Feel free to work, kind of bouncing ideas off each other. Everybody at home, you are more than welcome to stay on and ask questions as they arise, or you can feel free to get off the Zoom. But please don't hesitate to get back on if you see that there's a question that you want answered as you're working on these. Does anybody at home have questions? So again, tomorrow we're going to continue reviewing for your Monday chapter 6 test, 60 points on Monday. All right, if you're at home and you're leaving, have a great day. We'll see you tomorrow.